Now we will see the fundamental issues in hardware and software co-design. Whenever we are developing the embedded systems, we do require hardware and we do require software. So when we are thinking of software, we have to see the different parameters. When we are thinking of hardware, again, we have to see different parameters. So before implementing, we have to design. So for that purpose, we will see some of the issues with respect to hardware software co-design, because now we are going to use both. And so before developing, before implementing, we have to design. So first, we will see with the model selection. What is this model selection? It mainly captures and describes the system characteristics. A model is a formal system consisting of objects and composition rules. I hope you have studied in software engineering the different models, waterfall model, Boehm-Sperry model. So likewise, here also, we may use any of those models depending upon the type of applications. And this model mainly consists of, it describes the system characteristics. It mainly describes the system characteristics which has got different objects and composition rules. So all of you know, waterfall model has got its own characteristics likewise. So it is hard to make a decision on which model should be followed in a particular system design. Many a times it becomes crucial for the developers which one to follow, because certain part of the system could be built using one model, and other part you feel like using the other model. So it is always a challenge for the designers to choose a precise model. Most often, designers switch between a variety of models from the requirement specification to the implementation aspects of the system design. So this is again um, the entire process, the life cycle of software development. So this you would have come across. Any software development starts with the requirement specification. So that's what they're telling. The designers will be switching between the models from the requirement specification to the implementation aspect. So till that implementation, it's still till they start the actual implementation, they keep switching over between the several models. The only objective is it, and these objectives vary with each phase. And because many a times the requirements keep changing, so the objective changes. So henceforth, this makes the designers to opt for different models. So now let's go to the second selection. Other one is the architecture selection. So what is architecture selection? A model only captures the system characteristics and does not provide the information how the system can be manufactured. That's what I said. The waterfall model uh, used for the larger systems, and the Boehm-Sperry model wherein you keep checking the risk factors. So only talks about the system characteristics. You do this, you do that in this phase. That's it. But it doesn't tell how to implement, how to manufacture the system. Now, what are the things the architect in this selection? What are the parameters we have to see? The architecture specify how a system is going to implement in terms of the number and types of different components and the interconnection among them. Now comes, what are the different components involved? So now here it is not just software. We are also talking about the hardware. So what are the different components involved and how we are interconnecting? So all these things, again, we have to specify before you actually implement it. So some of the architectures that we see here is controller architecture, data path architecture, complex instruction set computing. So that is also an architecture we have seen. It has got its own features. Reduced instruction set architecture. This also we have seen in case of ARM, microcontrollers and microprocessors, that they follow the different architectures. Very long instruction word computing, single instruction multiple instruction multiple data. They are the commonly used architectures in the system design. Whatever we are discussing now is related to the hardware architectures. If you take the software architectures, we talk of different patterns, model view controller patterns. But here I'm talking about the architecture, hardware architecture. So we'll be discussing about the RISC, SIMD, MIMD architectures. Let's go to the next selection. Next comes the software. In case of software, which language you're going to select. A programming language captures a computation model and maps it into architecture. So it has to bridge a gap between the hardware and the software. So here we will be making use of both. Embedded system make use of both. So it has to map between the computational model and its architecture. Both it has to map. A model can be captured using multiple programming languages like C, C++, Java, etc. for software implementations, and languages like VHDL system, C, Verilog, etc. for hardware implementation. So for software implementations, we can go with C, C++, C Sharp, Java, and hardware we can go with VHDL system, C, Verilog. If you take ATM machine, it is a combination of hardware, and definitely there is a software inbuilt in that, because there is a software running which guides you. Which it is a there's a beautiful GUI. So the GUI is mainly using a software. So this particular programming languages should be user friendly also. At the same time, it should be compatible with the hardware. So language selection is another uh, challenge. So certain languages are good in capturing certain computational models. So certain languages are very good at certain applications. Like if you take C++, it is a good candidate for capturing an object-oriented model. If you are talking about different objects, object programming, then the best language to use is C++. Usually they make use of VC++ for embedded systems. So VC++ will help to develop many embedded applications. And the next one is, the only prerequisite in selecting a programming language for capturing a model is that the language should capture the model easily. As I said, it should be compatible with the model, the entire system, and it should provide a wonderful user applications. At the same time, it should communicate with the hardware. So this has to be done by the language that we choose. So now let's go to the next slide. Now coming to partitioning of system requirements into hardware and software. Now the question comes whether to opt for hardware or software. So here it is the implementation aspect of a system level requirement. So this is usually comes at the implementation level. It may be possible to implement the system requirements in either hardware or software. So the last semester we had discussed computer organization, wherein we discussed about the control unit implemented in hardware, that is hardwired control unit. And other one we have implemented using a set of instructions, that is micro programmed control unit. There itself you are seeing whether the entire control unit should be built on hardware, or whether you have to generate the control signals using the micro routines. There itself there is a uh, question whether to opt for hardware or software. In the same way, here also certain components can be implemented using hardware. Certain things can be implemented using software. So we have to partition. So which one should fall under hardware and which one should fall under software. Now, various hardware software trade-offs like performance, reusability efforts are used for making a decision on the hardware software partitioning. So trade-offs. So this is more cost effective, that is more cost effective, this is faster to implement, that is faster to. So in this way, we do a kind of comparison. So looking at that, which one is better? So ABC is better to be implemented in hardware, DEF is better to be implemented in software. So finally, we'll come out with that conclusion. So these things should be implemented using hardware, and these things should be implemented in software. So to come to that conclusion, we make a lot of trade-offs in terms of money, in terms of time, in terms of performance. We see all that, and then we come out with the model, which will be a combination of both hardware and software. So to summarize, we discussed today the different issues of hardware software co-design. The first one was a model selection. We did which model, that is a spiral model or waterfall model. Likewise, we do the model selections. Second one, the architectural selections. In case of software architectures, I told we will go for patterns, the different types of patterns. In case of hardware selections, we go with the RISC, etc. And the next one, the different languages. We saw that also for implementing software, we go for C, C++. Hardware implementation, we may use Verilog like that. And then based on all the parameters, we come to a conclusion. So the different components that has to be implemented in the hardware and software. So this is about all these things are applicable even for developing embedded systems.